In this video, we're going to go over how impulse is represented graphically. So we'll talk about how it is actually represented in the first minute, and then we'll go over a very representative problem where you have to solve a graphical question with impulse. So let's firstly start by looking at our information, right? As we learned before, impulse, which is represented by letter J, is equal to force times time and is also equal as final momentum minus initial momentum. Now, I claim that impulse is the area underneath the force versus time graph. To prove it, let me show you a simple example of a force of 2 newtons that is being applied on some object for the time of 5 seconds, right? So t is equal to 5 seconds over here. Now, if impulse, the formula is force times time, and the force is 2, and the time is 5, the impulse is going to be 10 newtons per second, right? Impulse doesn't have special units, so the units are just here, newtons times seconds, because we're multiplying force, newtons times time, seconds. But as you can see graphically, right, this will be represented by the area underneath the curve, because this side is 5, and this side right here is 2. So the area of this rectangle is essentially 10 as well. Now that we know that impulse is the area underneath force versus time graph, let's take a look at a type of problem where this information might show up. So here we have a graph of a toy car of mass 300 grams. So I'll convert that to kilograms right away. 0.3 kilograms. That is initially at rest, so V0 is 0. Initial velocity is 0. A varying force is applied to the car over a period of 14 seconds, as shown in the force versus time graph. Find the final velocity of the toy car at the 14-second mark. So, in order to find the final velocity, right, if we're basically given a force versus time graph, we should definitely look for impulse. As we just learned, impulse is going to be the area underneath this graph. So in order to find the area, we should break down this shape, right, into rectangles or into triangles and rectangles. Just like this one. So let's start with this triangle right here. Remember that the area of a triangle is 1/2 base times height. So this base is 2, this height is 20. So it's 1/2 times 2 times 20. Right? Then, okay, the next part is going to be this rectangle over here. By the way, this would be a good chance to kind of stop this video and attempt to calculate the area on your own. And you can scroll forward and see if you got the same answer. But if not, feel free to also just keep watching. So this rectangle right here has a side of 4, and this is 20. So it's 4 times 20. Okay, then this triangle right here is 1/2 times the side is 1 and the height is 20, plus this one is going to have 1/2, also the base of 1, but the height is going to be now minus 20, right? So just like the force, impulse is a vector, so meaning impulse can have a direction. So it can be positive or it can be negative, right? So for this portion of the motion, impulse is negative. So make sure that you include negative sign if your area is underneath the x-axis, like right here. So notice actually these ones cancel out, right? And then you have final area over here. So 14 minus 8, 6, side 6, and minus 20. So plus 6 times minus 20. Well, if you plug all of this into your calculator, you will get minus 20 newtons times seconds as your final impulse. But how does that help us to find the final velocity? Well, it's time to remember the second equation for impulse, which is final momentum minus initial, right? Again, in this example, the only object, right, is the toy car. So mass. So momentum is mass times velocity minus initial momentum, mass times initial velocity. Now it said that the initial velocity is 0. So initial momentum is 0. So essentially it's just mass times final velocity. or our mass was 0.3 kilograms, and VF is what we need to find. So our J is equal to this, and our J is also equal to this, right? Because it's equal to change in momentum, and it's equal to force times distance. So finally, combining these two equations into one, minus 20 is equal to 0.3 times VF, or VF is equal to negative 20 over 0.3, which is equal to minus 66.7 meters per second. So just like this, we found our final velocity. Great. All right. Now, in the next video, we'll start going over simple harmonic motion, another very important unit in physics. Until then, make sure that you practice a few of these examples on your own and keep practicing and keep watching these videos on your way to an A. Thank you guys for watching.